Hello and welcome to episode 31 of the Game Dev Tutorials. Today I'm going to do another Patreon request, at least what I believe to be the request, and if I misunderstood the request, let me know. We're going to make tiled backgrounds. So we've done a lot of work on our scene. A lot. We've started doing some work on the scene. And we can add things outside the grid, we can add things to the grid. But we don't have a background yet, and I think that's probably why it was requested. So to do that, we're going to create the file and overload basic 2D. I'm going to show you the tiles that I have. Again, these are from my old Delinar TD game. They're not the greatest tiles. I'll be honest, we didn't really know how to make tiles. We were kind of guessing, and they're okay, but they're not spectacular, but they're what I used to make a game at one point. So, hey, cool. We're going to discuss the issue of tile overflow. This is the main issue that you're going to run into when you're doing tiled anything. And we are going to solve that programmatically. We'll also, show it to you on the screen here. And then we're going to add this to the pipeline, and then we are going to test it. And that should be that. Now, that's a little easier than said than done, but we'll go over it. So this is a dirt tile that I have for you guys. It's all retarded. I hate the highlight around it. Anyway, I have this grass tile and a snow tile. Okay? That's what we have. And then, so here's our overflow problem, right? So actually, let me go into grass. Grab another one. Whoops. Can't do anything right. There we go. Alright, so the tile overflow problem is when you have a tile, this is our background size that we want, right? This outline. Okay, that's our goal outline, or background size. And these are a bunch of tiles, and then we have that happen. Okay? So what we have to do we have to either A, be okay with that, and that's, for beginning programmers, you probably could hide the fact that went over and do all kinds of wonderful things. It may not be important to you. Maybe your screen doesn't scroll that far, yada, yada, yada. There's lots of things that make this okay, and you could just leave it be. But if you want to have this perfect, you have to only draw a certain portion of your tile. Now, we've done that in animated 2D with a sprite sheet. This is just a little different because you have to dynamically figure out what that section is. With the animated 2D, you're having an equidistant piece of a sprite sheet. Okay, so we have to cut that little piece off, and then when you go over here and you get a bunch of these, I haven't tested this. We may or may not overflow this properly. We are going to overflow just a little bit. There we go. And we're going to need to cut that. Then when you get down to the bottom, you're going to have something that's like that. So you're going to have to do it on both the left and right. And so this is the main piece that we are going to deal with today. The rest of it's relatively simple. There's a couple little things, but other than that, the tile overflow is our main topic today. Also, I guess this is a good time to mention, if you like this video, or in general this series, or this topic, or whatever, please make sure you hit that like button. It really does help me out. It gets the word out, and gets the views up, and people get to see the tutorials, and that way more people get to be helped by these. Same thing for subscribing. The more subscribers the channel has, the more likely that YouTube will show its videos, so make sure you subscribe if you haven't. And then lastly, there's a couple things that you can do to help support me. One of them is Patreon, and I am super ecstatic to have a couple Patreon people, and it's really touches my heart and makes it feel worth doing all these things. But also, I have other games, and you check those out. It'd be great if any of you guys played them, and I'd love to hear feedback. And then lastly on that topic, I have a new game coming out called Guilds of Delinar, and I have a trailer, so check out the channel. It's the previous video to this one. Just check it out. See if you like it. If you do, jump over into Steam, hit the coming soon page, and throw a wish list on it. That would mean a lot to me. But yeah, let's get moving on. First things first, we are going to create the file, and we're going to do that as an engine piece, engine class. It is output, not input. It's not really a data type, although, I mean, you could think of it as the one. To me, a data type is something you usually are not drawing. That's the way I think of it. Or sometimes you do draw it, but it's something that's holding specific amounts of data. This is not really holding new data. It's just an output style for a basic 2D. Okay, so here we're going to add new item. We have tile BKG 2D. Also, if you guys are hearing the rain, I'm not sure if my mic's picking it up or not. I love the rain, so it would be fine for me, but if it's bothering you guys, I'm sorry. I can't turn the rain off. I wish I could for this video. But anyway, it doesn't rain much in California. This is not much of an issue usually, but I have a nice, wonderful rainstorm happening, and for me, it makes me happy. But if it bothers you, I apologize. Okay, so first let's get our includes, because that's what we do. Shave off our extra namespaces. Let's make this thing public. Standard procedure, right? This is the stuff we're doing every time. And then it's gonna inherit from basic 2D. Okay? Now, we have our constructor, so we'll start that. Start with constructor, and then we'll talk about the one thing we need to add to this class for data. So public tile to BKG 2D. There we go. And then that needs, because it's basic 2D, we need a string, path, a vector2 pose, and a vector2 dems. Okay, we'll put those in here. So we're using the basic 2D element as our tile. So this piece is an individual basic 2D. But we need to know how big this piece is, right? How big do we actually want this thing? So that'll be our one piece of data. To do that, we'll create a 2D for it. So public vector2 BKG dems. So the dimensions of the entire background. And we also need to pass that in here. Dems. Boy. Oops. That was no good. Okay, there we go. And then this is going to be vector2 BKG dems. Let me do that, and we say BKG dems equals BKG dems BKG. There we go. Alright, so simple, but important, right? Now, this would be our normal setup, but we have a little something to do, and I want to explain that. This is one of the minor little things that you can do to make sure this always works. So right now, all of our tiles are 100 by 120, and we were just going to use the full size. But your dimensions could be different than the full size of the tile, and the code we're writing should work regardless of it. But what happens if you have a fraction on the end? So let's say I multiply my my vertical dimensions by 71%. Well, that's going to give me, or no, 71.5%. That's going to give me 71.5 pixels, which means every two tiles I'm going to have a 1 pixel gap. And that's no good. We don't want that. So what we're going to do is we're going to, on the dimensions, we are going to floor those dimensions so that there's never a gap. Okay? So here, we're going to say new vector2. Whoops. Can't type. New vector2. And here we're going to say math.floor. And then encompass, this is going to need to be a .x. And then we take the same thing and we do it to y. So this will rid us of any evil little decimal values that eventually will add up into a space, a 1 pixel gap. Now, if that decimal value is 0.1, then at every 10 tiles it'll have a gap. If it's 0.01, every 100 tiles there will be a gap. But if there's a decimal value, eventually you'll get a gap. You don't want that, floor it all. You don't want to ceiling it, then you'll have a gap every tile. That would be bad. So that. The next thing we're going to do is in the BKG dims, we are going to do the same thing. So let's grab this. And you could say, well, that doesn't make sense. Why am I going to do that? Well, you don't have to. The one time when this ends up weird is when the tiles line up perfectly and then there's a decimal value. Because then you're going to draw an extra tile you don't need to be drawing. Or you're going to tell it to draw, but it won't actually draw anything. So you're running all the draw code an extra time, or however many tiles width and height that you have. That's how many, or, well, it would just be width or height. But that's how many extra times you're going to run your draw function. And so you don't need to do this. It will look the same. This will rid you of that small little edge case of just extra draw calls, which, again, not a big deal. You run an extra even 50 draw calls, doesn't matter. But it's something, and if all of your code is wasting 50 draw calls, the next thing you know, you have a really laggy game. So this is a way to fix that. This fixes the breaks. Oh, I need another cren there. So those are two little minor things. Not doing this screwed me up for tiles for a while, and it's a dumb mistake, but I didn't do it. I thought about it, and I remember thinking about it. I didn't code it, and it really jacked me up for a while, trying to figure out why I had gaps in things, because going back and checking your own code is not always easy. Okay, so we've done that. We need to just override our draw function. Public override void draw. So this is overriding basic 2D's draw. I have something wrong with something. Error list. We're missing something. We're missing a friend. I thought. Maybe not. Maybe not. No, that's correct. Oh, these have to be floats. That's what we got. Yes, I was missing the pren, and then I'm missing these float calls. So that's a double that comes out of there. And then it obviously doesn't like doubles. It wants floats in your calls. Let's see. Float to double, float to... That's all correct. It just needs to be built again. Alright, there we go. Now, I mentioned we are overriding this draw call, because the draw call will just call the tile once. We don't want that. That's no good. What we want is to loop our draw calls out. So for int I equals 0, I less than, let's see, it's math dot ceiling. I'll tell you why in a minute. BKG dims dot x divided by dims dot x, and then I plus plus. Okay. Now why? Why do we have that? Why ceiling? So this is going to almost always give you a decimal value at the end. So 1.4, 8.6, yada yada yada. Well, I will still be less than, so it'll run, but I like to have nice round numbers. You do not actually need this. But this helps my brain when I'm debugging to see the numbers better. There's also pretty much like 2 instructions, which is when you can run millions and millions of instructions per frame. 2's not going to hurt anything. This helps me for debugging. You don't want to put it in there? Don't put it in there. Okay? I've told you. This is It helps me. It may not help you. You don't have to do it. There's no use for it other than for my brain. All right, so now we have J's. And then I hate that it collapses that. I need to probably go in and change that setting. Okay. And then instead of X's, we have Y's. Okay? Oops. Shift Y's. Capital Y's. Okay. So this is saying loop on X as many times as the tile fits into the backgrounds plus the overlap. Same thing for the height. Yeah. Okay. We're there. So what are we doing here? Well, first what we're going to do is we are going to just output it. So we'll have base.draw, and then we are drawing at the offset plus new vector 2, and then inside vector 2 we have, let's see, it's the dimensions dot x over 2 plus dims dot x times I. And then we'll talk about that in a second. Let me put in the y's and j's right next to it. So y, y, j. Okay. Why did I offset this by half? Well, because I am using the position here as the top left point. So let's go back to our bit here. The position is here. That's the position of the entire background right there. Not in the middle. Right there. That's how I'm using it. So in order to draw this from the middle, I have to offset it by half. So that's why we're offsetting it by half first. Okay? All right. Good. So this will draw tiles and won't worry about the overflow. If you're not worried about overflow, there's your code. It's easy. Done. Okay? But we are going to worry about overflow. So we are going to run this anytime that it's -1. So all but the last time on both X and Y. Okay? So the way to do that is say I less than math.ceiling bkg dims.x divided by dims.x. So we have that value there. So anytime you do that, what can you do? You can say on the outside float num x equals, and then you can do this, right? So we take this, do that, and this is because we wrote it twice, right? As soon as you write it twice, it is actually more efficient to just create a variable for it. Unless, of course, you're RAM starved. If you're RAM starved, then that's not true. But cast it to a float. If you are RAM starved, don't do what I just did. Whoops. This doesn't feel right. I don't know which one doesn't feel right. That one was it. Okay, so we have that, and we know we're going to do it for y as well. So float num y equals, and then we'll have. Oops. I already killed it. Let's do this. We'll redo this again. Y, y, num, y, num, y. Okay, so I is less than num x, and j is less than. Oh, this is -1. Sorry. And j is less than num y -1. Okay. Again, caching makes things more efficient. You're actually going to run this code, however, this many times by this many times, and it's important. So this is actually a significant instruction saver. On a decent sized background with a decent number of tiles, you're probably going to save hundreds, if not thousands, of instructions. So keep that in mind. Sorry, I needed a drink. Okay, so this runs all except for on the last of each of these. and this runs all other times. Now here is the complicated bit. It is not the most complicated thing in the world, but it is of what we're doing the most complicated thing we're doing today. So the first thing we're doing is we are going to find the total size that we need for our sliver, whatever you want to call this bit here, the remainder, the sliver, the non-full tile. So we're going to find the dimensions of the non-full tile here. So first, float x left equals math.min, and then the minimum dimension, the minimum basically takes the smallest one, so you feed in the answer you want to be the smallest, and then the absolute largest it can be as your minimum. So with a minimum, you feed in one of the values as your largest thing, and with a maximum, you feed in one of the values as your smallest thing. So it's kind of the opposite. So we're going to do that. We're going to say dims.x. That is the very largest we want this thing to be able to be. And then we are going to have a calculation to figure out what that piece is left. What piece is left here? So we have the bkg dims.x, and then we're going to subtract from that I times dims.x. That's that. Okay, so I is how many tiles we've already created. We can say, oh no, that's not right. No, it is right, because we started at 0. So I, if you discount the 0, the 0th one, that accounts for the current I. So it is the number that we're currently at. And then we multiply that times the dimensions of the tile. So that's how much space we've used. This is how much space we have. So the space we have minus the space we've used is the amount of space we have left. We're going to do the exact same thing for y. Oops. So we have that. We need y's. So y, y, j, y. Okay. So this is how much space we have on x left and how much space we have on y left. Cool. Now we need percentages. X% left equals, and math.min. Remember, with min, you give it a max. The biggest we want is 1. That a 1 is 100%. And then the other option would be our x left over our dims x. Okay, why do we do that? So this is how much we have left. This is how much the total tile space is. This is the percentage of the tile left. If that happens to be over 1, it can happen. Go back down to 1. We want the tile to stay 100%. We don't want to stretch it. Okay. Same thing for y. So we have y% left. We have y left. And we have dims y. Okay. I hope that's clear why we did those things, and what information that we found. The next thing we have to do is we have to write our wonderful sprite batch. So bear with me. This is going to take some time for me to type out. It's decently long. Okay, so globals.sprite batch. Oh, and then you might wonder, why are you not just adding this sprite batch to basic 2D? The answer to that is because I've never found a use for this exact code anywhere else, and I don't want to clog up basic 2D with a overloaded draw function that I never use again. If that makes sense. I only want to use overloaded draw functions in basic 2D for things that get used at least often enough to justify them being there. This does not. At least I have not. And the reason for that, I guess I should cover that real fast, is that you're doing a percentage, but always from the top left corner. There is code that's important, like for a variable upper left corner and a variable bottom right corner. And you can say, well, why don't you do that? Even more interesting is that not only do I want always from the top left corner and always, and the only variable is to the bottom right hand corner %, I also want to fit it to the top left corner, and that's the part that never ever gets used. Usually you want to draw in the middle here and then have that space here. Instead, what we're trying to do is we're going to put it here and we're going to find the middle and then make sure that it fits into this corner so that there's no seam. That's the part that never gets used again. At least hasn't ever been used for anything other than tiling for me. Maybe you'll find a use for it. In that case, add this as an overloaded function in your basic 2D. That's fine. I haven't used it in my work past this. And I'm not trying to say that I know everything, blah, 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 do what I said. No, I'm saying I haven't used it, that's why I'm putting it here. And then if you find a good use for it, hey, look, I can be wrong a lot, actually. So, don't hesitate to, edit what I'm doing. All right, so this is the destination rectangle. We need the source rectangle. These are most important things. We'll get to those in a second, though. I am going to read this part because too much. Just too much. Okay, so the next thing is color. Color.white. Yep, and then we have rotation, which is a rot. Really should be 0 for tiles, but just in case, you might create some kind of background that you can rotate the tiles on. This code won't work for that. You would have to do some pretty interesting geometry for that to work. It is possible, but this will not work for that. So new vector 2, 0, 0. Remember I told you we're going from the top left-hand corner. So there's that. New sprite effects. And then just a 0, because that's all you need there. All right, so this looks short, right? Yeah, these get really long. Well, really long is the wrong way to say it, but they're pretty long. Okay, so here we don't. In this one, we know where the position is because that's using position of the overrided, the position that's inside of the draw function. So we it's already there. We don't have to pass it here. It's not here. Okay, so we have pose dot x plus offset dot x plus dims dot x times I. Okay, let's go over it. So we need to know where the position is. That is, when it comes up, here. Then the offset of the screen, we need to add that on. And then the dims x times I. So remember we covered that. What dims x times I is, that is total space currently used. So we need to start there. Okay? That is the top left of our slot. So let's look. So that would be like right there, right? Or in this case here, or in this case here, okay? That's where we're at, x-wise. We're going to do the same thing for y. Now, and then rectangle always wants ints. So make sure you cast those as ints. We'll do that first this time so we don't have to go back to it. And we're going to do the exact same thing for y, so let's just copy paste. And then Y's and J's. So there we go. Oops. Y, 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 J. Okay. Next tidbit. This is the total width. So our total width is first our int. And then math.ceiling. And I haven't rethought about why I'm using ceiling here. I'm not 100% sure that it's needed. I grabbed this code originally from Animated 2D and then edited it. So I assume it's what's needed. It worked in all the testing, but I haven't rethought about why that's there. So just keep that in mind. Okay, and then so we have dims x times x dot percent left. Okay, so that gives you a percent, rounds it down, seals it, does the ceiling, And then we're going to do the same thing for Y. Take that. And we are going to change these out. Y. Y. Okay. That is our first rectangle. Our second rectangle is quite a bit simpler. 0, 0, because that's where we're placing it. We're always, sorry, this is our source rectangle, so it's the top left of the source material, which we always want. And then here we are going to say X% times my model dot bounds dot width, I think on this one, yeah, width. And then the same thing, oh, that has to be an int again before it yells at me. I'm not used to casting to ints. Yeah, I only really do it on rectangles. Not only, but that's the majority of when when I'm casting to ints, so bear with me. Whoops, hate that part. Okay, and we paste in here, and then Y, and this is height here. Okay, so that should be it. So this is the percent of the source width and source height. Actually, here you could just use Y left and X left and Y left instead of the multiplications. I did these before I created X left and Y left. I rewrote this entire thing just to put that out there. I didn't actually like the way I did it before. This is better, but because of that, you end up with little things like this. I'm not going to change them because if I'm wrong, then it'll break everything. I don't want to deal with it. But I'm 99% sure you can use X left and Y left here, and then you could actually get rid of the ceilings because you already have ints here and ints here, so they're all ints. But regardless, okay, so this is our wonderful sprite batch draw. Okay, I believe this is all correct. This is a small amount of code, but it does, you know, a cool thing. I'll grab a drink real fast. All right. Now we need to go into world, and then I should mention the way I do things and the way that you could do things. I am going to just put this here in world, right? Just right here. So tile BKG 2D, or you can just call it BKG. Let's just call it BKG. Okay. You could put this in your level draw manager if you felt like it. The reason I'm not going to do that is because I'm not used to doing it that way. My level draw manager is a relatively new addition. As I told you when I was making this thing, I think it was 1 or 2 episodes ago. Anyway, I think it was last episode. I was faking level draw manager for a few games, so I got used to having backgrounds separate, so that's just why I do it that way, because I'm used to it. You absolutely could roll this into your level draw manager if you felt like it. In fact, I would say it's probably the overall better way to do it. But again, I'm not used to it. I won't look for it there, so it doesn't do me a whole lot of good to try to do that. Okay, so here we go in world. We're going to say BKG equals new. You know what I haven't done? I haven't added our art files. And so we have UI backgrounds, and then I'll say no, we'll just put them in here. I was going to make a tiles folder, but no need. Alright, let me grab those real fast. 1, 2, 3 X and B's. I will provide these. If I forget, let me know. Where was I putting them in? Backgrounds. Okay. Content, copy of newer. I am partially colorblind. So, the red imps on the grass background are near ridiculous for me to try to see without focusing on them. I'm not red-green colorblind, but for whatever reason, when you have red and green, it's in my peripheral vision, I can barely see it. So, just letting you know, there are other colors that do that for me too. It's not just red and green, but we are going to use the dirt for that reason. Use whatever you want, but for me, I need to use the dirt to be able to see things properly. Okay. Okay, so we have it's a tiled UKG. Okay, so we have the string to go where we need to go. We have vector 2, a new vector 2. -100, -100. Why, might you ask? Well, that'll cover more than just the grid. Okay. New vector 2. This is our total dimensions. So we'll pass on that for a second. And oh no, that's our that's our tile dimensions, which is 120 by 100. And you can see that in here. And then you can just say image. Of course it's doing something retarded. God knows why. Canvas size. Okay. We're using the full thing. Why? Because it's already super low res. So we don't want to shave it down anymore. New vector 2. And this is our total dimensions. So to get our total dimensions, we have grid dot total physical dimensions x plus 100 to make up for the offset, and then grid dot total physical dimensions y plus 100 to make up for the offset. Okay, so that's that. This is our thing. Oh, you know what? We need this. So it's 2D UI background standard dirt. 2D UI backgrounds standard dirt. Okay. Cool. Doesn't like something. 2. Need 2. Okay. Awesome. Did that. We are going to update this Mamma Jamma. Are we? Are we going to update it? I don't think we need to update this Mamma Jamma. We do not need to update this Mamma Jamma. If you wanted to use an animated 2D for a background for some reason, you would need to update this guy. Otherwise, you don't. Alright, so let's go down to our draw. And it's background, so it's the very first thing that we draw. Dot draw offset. Okay. So we should now have a background behind everything that works as designed. Hopefully I didn't break everything, and we have a set. Alright, so you can see the 100, see it got our trees in there, and then it goes for a while. So that is our background. You can do whatever you want with that thing, but you can see, unfortunately, the edge of the tiles are right there. We tried to hide them a little bit. Again, we were really bad at what we were doing. So these tiles are easily noticeable, but they're free, so go ahead and use them. This is dirt. We have a grass. We have the snow. And that'll do it, guys. So remember, like button, subscribe button, Patreon, other games, support me. That would be great. I really do appreciate it, guys. Like I said, this is directly from a request from, or what I believe to be the request from a Patreon. And, you know, that's why I'm doing this one. Yeah. I hope you guys liked it. I hope you guys enjoyed it. And I will see you guys next time. Have a good one.